So because some of your friends couldn't attend the class, okay, but if possible, all of you try to attend because it's different. Because if you attend the class, you can ask me or you can able to understand it maybe better, okay. Rather than okay, Dr. Raimi will share the recording. No need for me to. I can see later. Then then nothing happen. Okay. So okay. So the outline of this is some of that already covered by my previous lecture that I asked you guys to watch. Okay. So I will not do the repetition. You can refer to the previous lecture. Okay, because it's the same thing. Okay, it's the same thing, and actually you have the flexibility to watch it sooner even. Okay. So, the outline for the topic 3, number system part 2, we have a generic number conversion, we have binary addition, sub multiplication division, sign magnitude, first complement, two's complement, and two's complement addition and subtraction. This is for the operation involving two's complement. So these two have been covered by my previous lecture. Okay. So actually it's easy. You can just subscribe to my channel. Okay, you can unsubscribe later. Never mind. For me, it's okay. But it's easy for you to to see. Okay, electronics. Okay. So here you actually learn about the multiplication and the operation involving the binary. Okay. So you have this is week 2. Then you have a week 3 here. Okay, where I teach you how to do the subtraction and everything. Okay, and this is has been told to be watched before. Okay, to be watched before, so it's already there. Okay, I cannot do recording so much now on the physical like this because my handphone have full memory. And this iPhone not easy to transfer the memory. Okay, so please watch this and maybe you get this inside the quiz. I don't know because I say it's covered by the previous lecture as well. Okay, maybe it is as in quiz. I never know. I know what cover, but you need to read study. Okay. Okay. So close this. Okay. Today we will go to the other types of number system, which is sign magnitude, complements, and two's complement. So I will use, okay, most of the time during this lecture, I will use a module. Okay, I will use module to explain to you. Okay, so I think this is better because it will help indirectly those that didn't have module. So I will explain using module, the formula and whatever that is easy to be used to teach during lecture. Okay, and the slide you can refer yourself. Okay, the slide you can refer yourself. You can try, for example, like this. Decimal base 10 to base x conversion. Use repeated division with division by x. So what is this? Okay, you can try this exercise, base x to decimal base 10. Okay, using summation of value to the power of bit position, convert Rn, R1, Rox to base 10. Okay, so this one is addition. This one is 6 plus 3 binary. So what happened in this kind of okay, I'm wait how to sharing the screen. Where sharing this? Okay, so the question here, you see, it is about 6 plus 3 binary. So this one is, the question is 6 plus 3 in binary. So what you should do is actually you should convert it to the binary equivalent first. Okay. Wait, oh, wait, my laptop hang because of the recording, but nothing I can do because I want to record. Yeah. Okay, so 6 plus 3 binary. The question is asking, telling you is 6 plus 3 in binary. So what first you must do is actually you need to convert. You need to convert 6 in binary first. Then you convert 3 in binary first. Okay, what is 6 in binary? What is 6 in binary? Okay, so 6 in binary is 1 1 0. Okay, and then 3 in binary is what? 3 in binary is 0 1 1. Am I correct? Okay, so but this is for binary. Okay, but this one is for binary. What if we ask BCD? BCD is what? What is the answer for 6 in BCD? Yes, correct. Because BCD must be in 4 digit. Okay. Only then you can sorry. Okay. Then you can perform addition. Okay. It's different. Okay. So that was it. And you can try this. This one also been taught in my previous lecture video. Okay. Uh, what is happening here? Okay, so borrow and difference. So it's different. If you are if you're adding, you have carry and sum. But if you subtract, you have borrow and difference. Okay. So this is multiplication, pretty much straightforward. 0 times 0, 0, 0 times 1, 0, and so on. Okay. So this one is repeated definition repeated. So you need to transform 31 into binary first, and then you convert 5 into a binary as well. Okay. Then you do repeated division. You do the division. Okay. So now what we will go is actually the number representation. Sign number in digital sign magnitude, first complement, and two's complement. So close this. I don't want to use this. So we will use the slide and we will use the module. I will take some of the module to teach you. Okay. So that I think that is better. Okay. This one is no meaning. This one is quiz, but not the same as mine. Okay. Okay, so what we will do is that we go to the module, okay? So open to those that does have module, to those that have module, go to page 31. For those that didn't have, it's okay. Okay, I'm summarizing. Okay, I'm summarizing. So page 31 for those that have module. So natural bit number are the basic form. So we have first we have natural bit numbers, okay? So this is basic form. They always positive. Okay, and the smallest value is always 0. So this one is always positive value. With the smallest one is 0. Okay, smallest one with 0. So the simplest binary numbers are integer, meaning that okay, the simplest number is integer. Okay, means it doesn't have fraction. What does it mean? You doesn't have 1.01, 1.21. No, you will have a whole number, which means 1.0, 2.0, 3.0, and so on. Okay, this is what we call as general binary number. And this natural binary number doesn't have negative. Okay, it's only positive, and the smallest one will be 0. So if we want to represent it, okay, value, okay, for n bit, Okay, this one is the total bit. Okay, value for n bit integer bit pattern. Okay, value for n bit integer bit pattern. Okay, this one we call bit pattern. Bit pattern. Okay. So, what is the formula? Okay, what is the formula for value for n bit? For example, here is 3 bit. So, value for 3 bit integer bit pattern. So, the formula is a value unsigned. Okay, is it clear? Is it clear or sorry of my bad handwriting? I don't have a good bad handwriting. I don't have a good handwriting. Okay. So, V, then you have unsigned means there is no negative value, only positive, and smallest one will be 0. Okay, so V unsigned is that the unsigned number doesn't have negative. Okay, so the value is that sigma. Okay, this one is to denote addition. Okay, starting from 0 because we have smallest value to be 0. Okay, and then our maximum is n minus 1. Okay, then bi times 2i. Okay, this is the value. So, for example, okay, find the decimal equivalent. Okay, the question, find decimal equivalent of binary 10110. Okay, this one is later on. Okay. So, the number of bits determine the maximum combination of information. N bits. Okay, so this is n bits. Okay, allow storage up to 2n. Okay, so this will allow storage up to 2n. So if you have a 10 bit system, if you have 10 bit system, so you have 2 to the power of 10. So it's equals to what? Combination. It's itself equals to what? 2 to the power of 10. Where is my calculator? 2 to the power of 10. So this will be okay, 1024. Okay. So mean it will have storage up to, okay, storage up to 1024 combinations, okay, because 2n, okay, 2n to the power of 10, okay. So now we go for this question, okay. I put new page. I open new page. So next we have a question, find the decimal equivalent. Okay, decimal equivalent. Wait, so uncomfortable. I need to move the laptop. Okay. So the decimal equivalent. Okay. Decimal equivalent of binary. Okay, the question is find the decimal equivalent of binary 10110. Okay. So using the value that we studied just now, okay, the equations V unsigned, okay, equals to sigma I equals to 0, n equals to 1, bi times 2i, which is superscript. Okay, so we unsigned that we have, okay, find the decimal equivalent binary of this one. Okay, so the first one will be I0, right? I0, and then we have how many bits here? We have 1, 2, 3, 4, 5 bits. So we have 5 bits. So here will be 5 minus 1. Okay. Five minus one will be 4. Okay. And then bi mentioned here is bi is I equals to, okay, wait, okay, sorry. Okay, so here we have I equals to 0 and n equals to 1, which is, this one is 5 bits. Okay, 5 bits. So 5 minus 1, you will left with 4. Okay, and then bi times 2i. Okay, times 2i. Times 2i. Okay. So what happens is that you need to split. Now you have I0 until 5 minus 1, 4. So you need to mention, first case is I equals to 0. Okay, I equals to 0. This one. Okay. So first is that I0, B0 is actually 0. Okay. So to simplify your case, and to make the view look easier, so you start with most significant bit first. Okay, you start with most significant bits. So first is 4. So B4 times 2, B4 times 2 to the power of 4. Okay. So B at position 4, okay, B at position 4 times 2 at the position 4, okay, 2i. Then, because it's summation, you need to another plus, okay. And then the next one is you have 4, now you have B3, okay, B3 times, again times with the places of number 3, which is here, okay, which is here, which is 2 to the power of 3. Okay, and then plus again. So you have 4, 3, and you have 2 now. Next, we have B2 times 2 to the power of 2. Okay, so you have 4, 3, 2, and what about 1? So you have B1 times 2 to the power of 1. Okay, 1, 2, 3, 4. Okay, and the next one, what you will have is that B4, B3, B2. Okay, the next one is you have B0, okay, plus B0, okay, because it's 0 here. And then plus B0 times 2 to the power of 0. Okay, so you solve it further, you give value to B4. So what is B4? What is the B4 value here? Okay, so B4 is actually 1. Okay, B4 is actually 1 and 2 to the power of 4 plus B3 is what? B3. B3 is what? Okay, B3 is 0, correct? Yes, correct. Good. B3 0 and then 2 to the power of 3. And then plus B2 is having 1 and 2 to the power of 2. And then you have this B1, which is actually 1 times 2 to the power of 1 times B0. Okay, now B0 is 0. Okay, 0 times 2 to the power of 0. So in the end, you will get answer 22 base 10. Okay, 22 base 10. Understand? So far, okay? So far, okay? Okay. I will, okay, next. This is the sign magnitude in order for us to able to, okay, maybe this one I put into slide. Okay, I put into slide. Okay. Okay, the next one is why we need the sign numbers. Okay, sign magnitude, one's complement, two complement, because you want to show a negative digit in terms of digital. Okay, so we need some trick there in order for the bit, the combination of it to show the value of the to show the sign negative. Okay. Oh, what is this? Okay, so three major scheme. We have sign magnitude, one's complement, and two's complement. Okay. So next, we go to okay, we still further to the sign magnitude. Okay, for the sign magnitude SM, I just use SM here to save our screen. Okay, for the sign magnitude, wait just now am I? Oh, sorry, this one is unsigned. Okay, this one is unsigned. Okay, unsigned. Now we go to the next one is sign magnitude to make it negative. Okay, so go to the page 32 for those that have module. So we want to show the digital numbers having negative value. How we're going to show it? So one of the three ways, sign magnitude, then you have another one's complement and two's complement. So for the sign magnitude, okay, representation use the most significant bit MSP to indicate the sign. Okay, for example, if you have this number, okay, so can someone tell me what is this value in decimal? In decimal? 100100. What is the number here? So 51. Okay. And then so and then how about this number? How about this when then how about this number? The same, but we have one here. So what is the number here? What is the number here? It's just the same as this one, but it have one now. What is the value? The value is negative 51. Okay, because this to show it is negative. Okay, by having sign magnitude, this will be showing the negative or positive of the numbers. Okay, so this is the general one. Okay, so means that everything that you have in front, okay, for the sign magnitude, you need to be sure the question is about sign magnitude. If you have one in at the front, it will be mean that the number is negative. Okay. Okay. The formula V SM, okay, for the sign magnitude equals to, okay, VSM equals to -1. Okay, okay, you see here it's already have a negative element and to actually negative the entire digital numbers. So you have B -1 and you have B n -1. Okay, B n -1. Then after that, you don't need to memorize this. If you understand it better. Okay, but I'm not sure is this provide or not in the. I need to ask the coordinator. Okay, V -1 B n -1 and then times. Okay, in the sign magnitude is different. In terms of unsigned number is different. So in the sign magnitude, we have to multiply with summation of I equals to 0, n equals to 2 times bi times 2I. Okay. So v is some magnitude. Okay, for example, if you have a number 1010, okay, if you have number 1010, okay, so means this one you have how many bits? How many bits you have here? How many bits? It's 4 bits, so 4 bits. Okay. Anyway, you guys, honestly, I feel a bit sleepy. Yeah, I feel a bit sleepy because it's already after lunch and also because of fasting maybe. But you need to listen. I think some of you maybe sleepy also. Are you sleepy? I feel sleepy. Wait. Wait. Oh my god, I feel so sleepy. Wait. You guys have class or not? Maybe we can check first. You guys, you guys have class before this? Before my class, you have class or not today? Oh, yes. Okay. Oh, this is our last. Yes, this is also my last with you. Then I have other things, but I want to go back home. I want to go back home first. Okay, wait. Oh my God, feel sleepy. Wait. If you sleepy, if students sleepy, oh yeah, I mean if you are sleeping, it's okay. I think you can still record. But if I'm sleeping, then who will record? Okay, it's okay. I'm joking. Okay, but I'm really sleepy. Okay. So now, so for this example, okay, let me know if it's too small. Look too small. Okay. So now, this one, okay, negative. You see here, summated. We already reserved -1 here. So for this case, okay, -1. Okay, bn, not political parties, but bn n minus 1, you will have a b, this one 4, right? So b3 times, okay, times in bracket, okay, in bracket, and then I from 0, okay, we put here first, I equals to 0, and here is actually n minus 2, sorry, n minus 2, so 4 minus 2 is 2, times bi times 2I. Okay, so means from 0 until 2. Okay, so we start with 2 first. Okay, b3 is, sorry, so what is b3? B3 is this. B3 is what value? 1. Okay, and then times we have now from 2, we need to take the position of 2, okay, which is b2 times 2 plus b1 times 1, then plus b0 times 0. Okay, so -1 times b2, we have a 0 times 2, okay, plus b1 0 times 1, plus b0, which is this one, 0 times 0. Okay, is there anything I do it wrong? Wait, b1, oh, b1 is 1. Yes, b1 is 1. Oh, okay, you see, I see. Oh my god, because I'm sleepy. Even simple thing also make it wrong. Oh, okay. So this one is 0. Can you guys see? This one is 0. This one is 0 because everything divided by times by 0 is 0. So then this one is -1 to the power of 1. You still have -1, and then you have 1 here, and you have 1 times 2, which is 2. So the value is actually -2. Okay, but understand, this is sign magnitude with the number that have if the most significant bit have 1 for sign magnitude, means it is a negative number. So if you want it to be positive number, you can see, right? Positive number is you will have 0, 0, 1, 0. Am I correct? This one is 2. But for the sign magnitude, okay, for the sign magnitude, if you want to show it's negative 2, you need to put the most significant bit to be 1. Okay? Okay, understand? I think this teaching is good because I will use module, means indirectly it will help those that didn't have module. Okay? So I write properly. Wait, I put in the module my beautiful handwriting. When you when you work later on, maybe you tired, even your hand, maybe initially your handwriting is beautiful, then become disaster because you are too tired even to write. Okay. Okay, so I put here. Okay. So this is you can find whatever here. Okay, because it's just the same as what I teach you guys. Okay. So next one. Okay. So we have studied about this similitude. Okay, we have studied about this similitude now. Okay, the similitude is not perfect. Okay, similitude is not perfect. Similitude is not perfect. So one of the drawback is that it cannot differentiate positive 0 and negative 0. We cannot differentiate this. Positive 0 and negative 0. By right, both of 0, but we have the sign. It cannot compare this signation. Okay, whether it is positive 0 or negative 0. Okay. So therefore, it is not the best for machine efficiency and lead to problems. Okay, when we want to do addition and subtraction. Okay, okay. Please take note. Because of that, it is a cumbersome. It leads a problem if we want to do addition and subtraction. So the second drawbacks. Okay, this is the first drawback. The second drawback is that the adding of the same number with opposite sign cannot be done by simple addition. What does it mean? Let's say if you have a number of negative 4, okay, and you want to plus it with 4, it should produce what? It should produce what? Negative 4 plus 4. Yes, it should produce 0. However, with sign magnitude, this is the problem. Negative 4 plus 4 will produce 8. Understand? How this happen is that we try to convert this to binary. Okay, this one is base 10. All of it is base 10. So negative 4 is what? In sign magnitude. Anyone can tell me? In sign magnitude, what is negative 4? In sign magnitude. If it's positive, is what? If it's positive, is 4, negative 4. Okay. In what? I'm asking anyone answer. Okay. For the positive 4, for the 4 is actually 0, 0, 1, 0. Okay. And then for the negative will be 1, 1, 0, 0. Am I correct? Okay. This is for the 4 bit. But if you want to do the binary using the sign number, so the initial negative 4 will be 1, 1, 0, 0. Sorry. Sorry, this one also wrong. Okay. So for the negative will be 0, 0, 1, 0. Okay. 0, 0, 0 plus with 1 because we have sign magnitude to show it is negative. Okay. And then plus. Okay, plus with the positive number. Positive number, nothing different. Okay, so what do you have when you add this number? Can you tell me what is the number? Can you guys tell me what is the number when you add them together? Not zero. You can see this. What is the answer? In 8-bit. What is the answer? Can you guys tell me what is the answer? No, it's for 8-bit. Yeah. So 1 0 0 0 1 0 0 0. So you can see here, okay, it will produce what? It will produce 8. Now you can see the error, right? It produced 8 because this one is means the sign negative, and this one is 2 to the power of 3. So it is not accurate. Now you understand, right? There is two drawbacks of using a sign magnitude. Okay, first you have this 0 is like this, two representation of 0, and then you cannot add number that have uh, the same magnitude but different sign. Okay, it will not equate properly when you do the when you want to do the addition. Okay, again I will take my masterpiece here, my art. Enjoy my handwriting because it's the most beautiful handwriting that you ever see in the entire world maybe. Oh my god, I'm sleepy. Okay, so this is the disadvantage. Okay, now um, now we go for the ones complements. Okay, so another way in describing the negative number is that ones complements. Okay, so what we have studied just now is unsigned number, V unsigned. This one is for normal one. Then you have V sign magnitude. This one is to help you to show the negative numbers. Okay, but it is not perfect. Now we go to the next representations. Okay, next representation, which is the ones complements. Okay, ones complements. So ones complement is that the word is here like this, ones complement. Okay, the way you should write, okay, in ones complement, the value for a bit pattern, value for this one is V, means value. V means value for a bit pattern. V is actually means value for a bit pattern. Okay, okay, value for a bit pattern. So one's complement is that value for one bit pattern is V, then 1C. Okay, to show it as a one complement. Okay, equals to, okay, equals to negative B. I think you just see this and then okay, because I think more unknowns come out, but it's actually simple. It's actually simple when we go through the example. B n minus 1 and then 2 n minus 1 plus, even to write this already make me tired. Sleepy already. Ni equals to 0. Okay, and then n equals to minus 2, and then bi times 2 to the power of I plus b n minus 1. Okay, wait. Okay, I think it's okay now. So in n bit we can represent, okay, never mind, I will go later on. Okay, in 1 bit we can represent values between, okay, this one I will go through to you together when I'm summarizing, when I'm summarizing all the all the numbers. Okay, so what we do is that in one's complement is that the one's complement form a negative binary number is the complement of its positive counterpart, which can be obtained by applying bitwise not operator to the positive counterpart. You don't understand? It's okay. I'm reading now. I'm reading to you because you don't have the module. Okay. Let me reading for you. Okay. In n bit, we can represent value between x and y. This one I will summarize later. The one's complement form of a negative binary number is the complement of its positive counterpart, which can be obtained by applying bitwise not operator. Not operator you will study after in the subsequent chapters to the positive counterpart. Like sign magnitude representation, one's complement has two representations. Okay. Okay, blah, blah, blah. Okay. So just go to the example. I think it's easy. I think maybe you guys also tired. Okay. Just go to example. Okay. So the example again, for example, find the value find the value of the bit pattern uh, 1010 interpreted interpreted in one's complement notation. They will tell you this is you need to solve using sign magnitude, you need to solve using one's complement, you need to solve using two's complement. Okay, so you need to be aware of that. Okay, notation. Okay, so you can see here is how many bit you have. N equals to 4 bit. Okay, I put different color so that you easy to differentiate. We use different color now. So you see this is n equals to 4 bit. Okay, and then okay, we directly implement the this one. Okay, this formula. Okay, so first you have v1 complement negative b n minus 1. Okay, so you have 4, right? So this one will be 4 minus 1, 3. Negative b 4 minus 1 means 3, and then 2 4 minus 1 is 3. Okay, plus summation of all this. So next one is I0, means next one is start from this one first. Okay, which is 4 minus 2, you have B 2 times 2 plus next one is 1. Okay, because this one is 4 minus 2 is 2, right? So the next one is 1. So B1 equals to 2, 1. Okay, and the next one, the last one is 0. B 0 times 2, 0. Okay, and you see this one, the last one here, means plus B 4 minus 1, 3. Okay, understand? Understand or not? If you understand, clap your hand. Clap your hand is this at the WebEx check. Okay, only Joey understand. The rest what? What are you doing? Maybe next time I will ask you guys to teach. Next time I ask you guys to teach. Then you see. Oh my God. I think we have a lot of class replacement class this week. Never mind. It's okay. It's my job. Just I'm human, I'm sleepy. That's normal. Okay, so B3. Okay, you see B3 here. Okay, so B3 is what value from here? B3. So we put I put here first so that you easy to see 0, 1, 2, 3. So B3 is 1. Now we use the 1. Okay, and you see there is negative there. There is negative, so negative. Don't forget the negative. Okay, and then 2, 3. Okay, so that easy, so that you can see. So there is negative. Don't forget there is negative. Okay, and then B3 is 1, and then times 2, 3 plus B2 is what? B2 is 0 times 2 to the power 2 plus B1, which is 1, and then 2, 1 plus B0, which is 0 times 2 to 0 plus B3. B3 is 1. So if you can see this, everything, this one is 0, of course, and this one is 0. So you have what? So you have, this one is negative, negative 8. Oh, sorry. So this one is negative 8. Yes. Even to type, I'm very slow. Okay, it's okay. Then this one is plus 2 plus 1. Okay, so what is the answer, everyone? Kindergarten, negative 8 plus 2 plus 1 is what? Okay, good. Maybe you will be surprised, watching my doing my quiz later on. You don't laugh, you all. Quiz nanti, my quiz will not be that be easy, but I have a good intention so that you will be prepared for your test. Okay. Okay. So far, okay. Then I will take this, copy paste again. Okay, my beautiful handwriting put here. I don't care if you vomit blood or not, but at least I put here. Okay. Okay, put here. Because I want to help those. Okay. Then I need to make it big, because it's already beautiful. Then we make it more beautiful by making it more large. Okay. Can you see this? Okay. Okay. We make it even larger. Okay. So done with that, which we call it first complement. Okay. So what actually the first complement trying to do actually? Okay. Okay. So what actually happened in this is this is value for a bit pattern, V. Now what actually happened inside inside a one's complement system actually? Can you don't save? Okay. So what happened is that, for example, if you have a signed integer, okay, signed integer, what does it mean? Means it have positive or negative. This one, sign. Integer means the nombor bulat, round numbers. Okay. Then you have the ones complement. Okay, ones complement. Okay. So for positive 1 to 7, okay, you will have what? You will have 0, 1, 1, 1, 1, 1, 1, 1. This is for one's complement, positive. However, if you're going to have negative numbers, okay, negative numbers for 1 to 7, what one's complement do is that you just flip. You just flip. 1 becomes 0, 0 becomes 1. So it's easy, right? Easy, right? Or no one will say easy. Just say clip if you understand. Okay. So not this one. Understand or not? Just flipping. It's actually just flipping. You flip all over. Okay. So you just need to flip. Okay. So it's easy. Okay. Now, okay, flip. Actually, this one we didn't in your senior didn't study this. Okay, your senior. So you study. So that's why syllabus a bit different. Okay. But you still can watch my previous lecture video because it is very important. Très important. If you learn French, you know lah. Très important mean very important. Okay. Okay. So where was I? Okay. Now we need to study about the range. Okay. The range means for the sum magnitude from which number to which number, one's complement from which number to which number, and sorry. For unsigned number, from which number to which number, sum magnitude from which number to which number, and one's complement to from which number to which number. So before we go to the two's complement, okay, now we divide the screen first. We divide the screen. Okay. So first you have unsigned number. Okay. Then what we learn next is what? V what? What is the next one? V what? V what? Is I see. This one here is here. 1C. So SM, sine magnitude. Okay. So 3. Okay. So we learn this. Okay. So this is sine magnitude is 1C. So we will have the range from which value to which value. So for the unsigned numbers, we doesn't have negative value, and it also doesn't have fractional value, means round numbers. We don't have fractional number, we don't have perpuluhan, we don't have decimal points. So for the unsigned number, the smallest one will be 0. Okay. Until 2n minus 1. Okay. So taking into account n is actually what? Number of bit. Okay. Then how about okay. So how many combination possible in the unsigned number? We have possible combination of 2 to the power of n. Understand? Because it's including the 0, right? So we have 2n combinations. So if you want to store storage, okay, you want to do some storage information. So unsigned number can storage up to 2 to the power of n, okay, depending on the number of bits, okay. So the next is the sign magnitude, okay. The sign magnitude is having the value between -2, okay. I put here so that you can see the color. Okay. So -2 to n minus 1 minus 1. Okay. Wait, I need to make it very clear, otherwise you guys confused. Because not all of you have module. Okay. Wait, I'm trying to practice good handwriting. 2n minus 1. Okay. Good. 2n minus 1 minus 1. Okay. Until. Okay. Until which value? Until 2. Wait, charger. Okay. Until 2 n minus 1 minus 1. Okay. So this is the range of values. Okay. Okay. So you can count yourself how many possible combinations. Okay. Depends. Okay. And this one also I leave it to you. Okay. So if you want to see the VSM, okay, the sign integer, okay, I make another small table inside here. Okay, if you have the sign integer, sign in sign integer, okay, then you have another one which is sign magnitude. Okay, sign. Okay, so let's say you have the number here positive 127. Okay, if you want to represent in the sign magnitude, that nothing changed. We only have changes if it's negative numbers, right? So you have 1, 1, 1, 1, 1, then 1, 1, 1, 0. Then started to have different if we have negative numbers. Okay, negative 127. Okay, so what is the difference is that we have to add 1. We have to add 1 here to show it is a negative numbers. Okay, so far so good? Or you guys say what? So far so good, okay? Oh, I cannot put, okay. I cannot put thumbs up, huh? Where is the, for my, okay, never mind, I cannot do, huh? Okay, never mind. Okay, so now we go to the next one is the V1 complements, okay? So one complement says you flip actually, right? You just flip it. Okay, in n bits, okay, for the ones complement, the value is negative. From which value to which value? Negative to n minus 1 until 2 n minus 1 minus 1. Okay, so it's almost the same, right? Is it the same? Is it the same with VSM? Same or not the same? Same or not the same? The range, is it the same or not the same? One sign magnitude and one complement. Is it the same or not? The way you look at it, is it the same? Okay, so it's actually the same. Okay, it's actually the same. The range the same because we just change, it just a representation. For example, you use sign magnitude to represent negative number in this way. And then once complement, you present the negative value in this way. It's just different ways, but it's the same. Yes, it's the same. Okay, the range is the same. Okay, for these two. Then if we look into the table, if we look at the table for the sign for the complements, okay, one complement. Okay, again sign integer. Then you have one's complement here. Okay, one's complement. Or you can also put 1c lah. Is it 1c? Yes, 1c. Okay. So for the positive number, we didn't have any change. It's just the same. But we will have different if it's negative numbers. So what is the number here? We just need to flip it. But what is the number? We need to flip them all over. What is the number? Maybe you guys also sleeping. Yes, it's 1, 0. So you just flip. Okay. Okay. Finish with that. So I take this one. Wait. Okay. Anyway, maybe I give some tips for the quiz because okay, so for the quiz, make sure you know how to calculate duty cycle, pulse width. I didn't teach this, but I already asked you guys to watch. Okay, pulse width, and then you should know the high and low value. Okay, for example, if this is high volt, for example, is it considered as binary 1? And maybe you have transition region. So please watch, okay, the lecture video. How to calculate duty cycle, how to calculate pulse width, how to calculate frequency, how to calculate what else? Okay, try your best. Okay, how to calculate period. Okay, so all the best. Okay, the next one. Before I okay. Oh, very fast. Is it? Am I too fast or is it too fast? I don't know. You guys also didn't ask me, because for me it's okay, look like easy, because I'm lecturer. But you guys need to ask me if you don't understand. Okay. So next one is two's complement. We have two's complement, so two complement. Okay. So the wording is that 2C. Okay, two complement. So again, value for a bit pattern V two's complement equals to, okay, again just watch because later on example is more easier than this negative b n minus 1 to n minus 1 plus summation from I equals to 0 until n minus 2, and then you have bi times 2i. Okay, so this one is n. Okay, so the value of B to C can also be interpreted, okay, can also be interpreted as, for example, also can be interpreted as V to C equals to 2n minus V natural, means the natural numbers are the one that we learn first, which is the unsigned number. Okay, V natural numbers, the first one that we learn, so it's natural. Okay, so this one is natural, the one that we learned in the earlier one, which is the unsigned. Okay, which doesn't have negative numbers, and the smallest one will be 0. Okay, so for these two complements, okay, for these two complements, the range that we will have is actually from 2n minus 1, okay, until 2n minus 1 minus 1. Don't use this in exam. This one is for me to easy writing. Okay, means you need to write 2 until this or n. Value between 2n minus 1 and this, or value from this until this. Understand? Okay, this one is just to make me easy typing. Okay. Okay, so the same example. Okay, we refer to the same example. Find. Okay, I put different color. Find the value of the bit pattern 1010 interpreted. Interpreted. I need secretary, please. Please write for me. I'm lazy. In two's complement. Okay. Sorry. In two's complement. Okay. So you can see this is the value. Okay. So first you need to know how many bits. So you can see the bit is how many bits? The bit is 4. Again, the same. And then you have this as your B0, B1, B2, and wait. Okay, like this easier. Okay. So this is B0, B1, B2, B3. Okay. So using the formula that you see here, yang macam you look like a bit difficult. Okay. Not difficult actually because the way it write, but it's actually very easy. Don't worry. Okay. So now we try to translate into our V2C. V2C. Okay. 2's complement. Okay. So the first is negative. You see here, negative. So negative. Okay. Negative Bn minus 1 means 4 minus 1. So B3. Two n minus 1, 3 plus. Then this one is I0 until n minus 2. So we take the biggest one first. So 4 minus 2 is 2. So B2 to 2 plus B1 to 1 plus B0 to 0. Understand? Then after that B3, you get B3 is actually so B3 is actually 1 and then 2, 3 plus B2. B2 is 0. 2, 2 is equals to 2, 2 lah. B1 is 1, 2, 1 plus B0, 0 times to the power of 0. So this one, you know it is negative 0. And this one, you know it is a 0. So the final answer is that negative 8 plus 2. Okay. So everyone kindergarten, what negative 8 plus 2? Don't tell me you don't know. If you don't know, I ask you go to semester 1 again. Negative 8 plus 2 is negative 6. Okay. Easy, right? Okay, so I take this one. I take this one. And I put here. Where? You see, this one is even more pening. Headache. You can see this. Okay, I make it simplification for you already. Okay, so we don't waste our time. Okay. Okay. Then, what covered by the module after that is actually what have been covered by my. Wait, what else they teach you guys? Oh, sign extension. Okay. They still teach you something. Okay. Never mind. Okay. So next one. Next one is what they call it sign extension in a two component just okay. Oh, okay. Okay. The next one is actually sign extension. This one doesn't, I think not in the slide. Wait, I want to see the slide. Is it in the slide or not? Oh, okay, this one you can do. subtraction. Okay, this one not difficult. You try. You try first. The answer is already here. Okay, understand or not? The answer is here. Okay, you can try here. If you don't understand, let me know. Okay. So, oh, okay, it doesn't have the sign magnitude. It doesn't have sign extension. Okay, so the next one we will study is the sign extension. Okay, sign extension is the process, okay, of converting a number into complement. Okay, remember, sign extension is process of converting. Okay, I just put the keyword converting number into complement. Okay, to a larger format. Means if it's initially 16-bit, we want to convert it to 32-bit. Okay, so you can call it larger format. Okay, so far so good. Actually, maybe I'm not good. I mean, not good. I mean, my energy late already. Okay, so convert to complement to larger format. Okay, so for example, if you want to convert from 16-bit number to a 32-bit, okay, it is actually very simple. Okay, the rule is quite simple. Just copy the sign bit to fill the new high order bit. For example, I take the negative. Negative is the one that is difference. Okay. So if we want to have okay, what number? Okay. So initially, okay, if we have this number in the ones complement, in two's complement, remember two's complement. Okay. 100. I think I need to make this highlight so guys, so that you guys can see. Okay. So next one is okay. Let's say we have 1001 and then 1100. So how many bit is this? In two complements, how many bits? How many bits is this? This one is 8 bit. Okay. Now we want to make this number, okay, in terms of 16 bit. So 16 bit. So it is quite simple. You just extend the bit. 0011 100. Extend until 16. So 1111 1111. Understand? Easy kan? To fill the high order bits. Understand or not? This is sign extension. You just extend the sign. Okay. Of course, the positive nothing changed. Positive for positive you just extend the zero. So it's the same. Okay. For example, if these positive numbers, 0 001 1100, 8-bit, 16-bit, 0011 100, then you just extend one. Okay. What has the book teach? Okay, so we just extend the bits. Okay, so I take this. I screen. Wait. Put into our slide. Here. Okay. So the next one is we're going to study the next one. We call it offset binary. Okay, offset binary. Joey, can you snap for Joey, or are you because I keep disturbing Joey. Are you here? Do you have the module with you? Where is Ayu? Are you inside? Oh, you have class, right? Okay, never mind. Joey, can you snap table 3.4? The table only. The table 3.4. and then put into our Telegram group because I want to copy paste to our slide. Understand? Table 3.4, page 36.
Okay.
Okay. You do it first. I wait for you. Okay. So save as. Okay. Okay. Then insert picture. Wait. Okay. 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 Things okay. Okay. What else they call? Okay, the next is what we will study is the offset binary. Offset binary. This one also not that. Don't worry. No. Okay, the concept is easy, but you, when you answer question, jangan pelik-pelik lah. Okay. When you answer question, please make sure you know it. Okay. What is offset binary? Wait, I'm reading. Offset binary represent. Okay, I'm reading first for you guys that didn't have the module. Okay, I'm reading. Offset binary representation is a variation of the two's complement representation. Again, similarly like sign extension, offset binary is about two's complement representation. It isn't mention about one's complement sign magnitude. Okay, please take note of this. Okay, I read again. Offset binary representation is a variation of the two's complement representation. It is also called the excess K or bias K representation, where K is the offset value. And all zero pattern represents the minimal negative value. All ones represent the maximal positive value, and K represents 0. There is no standard for K, but for n-bit binary word, K is usually set to 2n minus 1. Bias representation are primarily used for the opponent of floating point numbers and for interfacing with analog to digital converter. The XS3 code, which is modification of the binary coded decimal number, use K equals to 3. Okay, blah blah blah. Okay, banyak pula. Okay, so how do I explain it to be easier? An O0 pattern represent the minimal negative value. When give me some time. It seems like not important this one, but wait. Because I never see this before being taught. Okay, I mean syllabus has changed. I need to dig my old brain. Very case of 0 and all 0 represent the minimal negative value. All 1 represent the maximum. Okay, wait for a while. 100. Bias means primarily used for the exponent of floating point number and for. Okay, this one okay, representation breakage the official value and all zero pattern represent. I also don't understand the English, the English they use. And all zero pattern represent the minimal negative value. All ones represent the maximum. Okay. Now and okay. So if you see this is the decimal, okay, I cut away similitude ones complement because we not discuss this. We want to relate it directly with our two's complement. Okay, and then we want to relate it directly with our offset, because offset binary also discuss about the two's complement only. Okay, so let's say for the decimal numbers you have 7, 6, 5, 4, and then going through here, then you have -4, -5, -6, -7, -8. Okay, so for the two's complement, okay, for the two's complement is we will have 0, 1, 1, 1. Okay, and then the next for the -8 is 1, 0, 0. Okay, and this one value in between. Okay, okay. So the maximal positive numbers, okay, we represent, okay, the maximal positive number we represent into all ones, okay, and the maximum, not the maximum, the most minimum we represent as all zero. I think this one not really important because too little the information given here, okay. There's no standard for K, but for n bit binary word, K is usually, okay, so no standard for K. However, for n bit word, okay, here mention a word, binary word, binary. I think this one is not important, this thing. Bit binary word, bit binary word. I don't know why they changed it. Okay, n bit binary word, okay, for standard n bit binary word. So K is usually set to n minus 1. Okay, so K is actually offset value. Okay, okay, so all one represent the maximal positive value and K represent 0. Okay, and all 0. Okay, and all 0 represent the minimal negative value and all 1 represent positive values. Okay, I don't think why we need this. Okay, but this is it. I don't think there's much can be asked about offset binary because so little information here inside. I also like wondering what suddenly see this offset binary. Okay, no. Okay, so I take this one. Okay. Okay, so the rest of the binary arithmetics. Okay, after that the module discuss about binary arithmetics, addition, division, multiplication, and so on, which have been discussed by my slide. Okay, which has been discussed my previous lecture. So you can watch my previous lecture. Okay, about it. Okay, and then the operation here actually just okay, wait. We go for similitude. Wait, I want to see if there is anything like okay. Find the equivalent decimal of the following ones complement. Okay, this one. Okay, please watch. Please see this one. Okay, please read. Okay, I think no, not so far. Okay. Okay, please do this. Okay. As your exercise, okay. Sign magnitude, how you present 0, 1's complement, how. Sign magnitude, we have problem, right? For 0, we have what? We have positive 0 and negative 0. Okay. This one, no problem. Okay, this one should be okay. Okay. Binary, and then the last of the module is asking about the binary. So when is the next class? When where is my calendar? When is the next class? I forget. Wait, I need to see my tomorrow. Okay. Okay, so tomorrow 2 to 4. So I will provide, okay, please enter e-learning. Okay, please enter e-learning maybe tonight or whatever. I will ask you to watch some lecture first before coming to my class. Okay, is it okay? I will provide the link. Which video you need to watch, because tomorrow is logic gates. I will give exercise group exercise 3 again. I will divide you in group. Okay, I will divide you in group and you need to do it. Okay, is it okay? I will do it and I will point different leader. Okay, group 1 the same member, only the leader is changed. Okay, you will need to do all the group 3 exercise, but not now. Okay, so okay, wait for a while. We finish about that. How to stop share and not stop sharing, stop recording, stop.